Okay. Yes, this is work with my students Muga and Kai at Toronto, and then Harold So in the US. Okay, so let me give an intro to this paper by giving you sort of a dream scenario for critiquing-based recommendation. Okay. So this is a news recommendation scenario. It is hypothetical, and example taken from December 2019. Okay, so I say, hey, news assistant, what's trending right now? Imagine it's June 15th or thereabouts, right? I live in Toronto, so it's going to say, hey, Scott, here's the top headline in Toronto. What happened then? Well, the Raptors won the NBA championship. So that's the top headline for that day. That's great. I live in Toronto. I actually know this already. So I say, great, can you give me some other perspectives on the Raptors win? If you go to the Bay Area, right, here's what Oakland thinks. Now, there's no mention the day after that the Raptors won a historic championship or that the Golden State Warriors lost, but they do care that there's a shoving match with the Raptors president. Sorry, Bay Area, but you guys are sore losers. Okay, fine. That's sports. Let's see what's happening in the world. How something more international. Okay, so here's unfortunately a multinational crisis making headlines. Go figure, it involves Trump. Okay, so fine. And this is from the Washington Post, and I note that we know the Washington Post is legitimate because it's on newspaper gray. If you go to the website. Okay, so you only note if you stand on a white background. Okay. So anyways, I've heard enough of Trump and crises. Can you give me something, a little bit more on the later side? So my news assistant at the back and says, here's a humorous international crisis. And you say, well, what could that possibly be? Okay, Trump. Consider possibly buying Greenland. Essentially, it's a large real estate deal. Okay, I'm sure the locals were very upset when Trump canceled his visit. Okay. Anyways. Okay, so what's new and interesting about such an interaction? It is a well-known scenario of critiquing, right? It's a great idea that's been around reference systems for years. But historical critique is largely based on explicit attributes, right? So movies have genre, director, actors, actresses, awards. If you're looking at restaurants, like cuisine type pricing distance, and apartment size, or bedrooms or bathrooms, distance of transit, right? All very explicit stuff. And historically, you saw a lot of work in the area of constrained optimization, right? That was heavily appropriate for these very explicit attributes. But I do want to ask in this talk, how does critiquing change in the era of deep embeddings, right? So to be more concrete, right? We have to look at a latent interpretation of critiques. For the example that I gave you, right? If I would interpret something on the later side, I have to look at, right, the language intent, the news context, what was the conversation history, the later side of what, right? It's not a trivial critique to answer, right? Okay, and the attributes of news are expressively latent, right? I mean, not everyone is going to find the Trump headline with Greenland humorous. I do, right? But these attributes are not necessarily explicit. Okay. And finally, it does involve personalized recommendation. Obviously, I want to leverage the preferences of the user, that's obvious. But I also want personalized explanations. I mean, maybe I find something humorous and you don't, right? The system should know, right, how to explain things to you. Okay. Now, for full disclosure, right, I'm not claiming in this talk or in this paper that we handled everything, right? This is my dream system. And in fact, you might be disappointed that we only handle sort of interaction with key phrases, right? So these are sort of simpler language-based attributes. But however, they're still not explicit, right? Again, the key phrase humor for the Trump article, that's not explicit. No one said that. It's personalized to me. So it's still latent. And I'm just looking at single-step critiques, and at the end, I'll give you some ideas that we're looking at for going sequential. Okay, so there's no math in this talk. I want to show you one key architecture, which is, I think, the key to the paper, right? So we built a neural collaborative filtering. Okay, so you start with a user embedding, right? UI and an item embedding BJ, right? Feed in some latent space Z and predict a rating, right? So that item IJ, you give it a rating. Now, neural collaborative filtering does reduce to standard matrix factorization if it does reduce the standard matrix factorization if the latent space is just a dot product to predict the rating. Okay. Now we want to extend this with explanations, right? So we're going to add another head for explanations. So we use data sets where you've not only provided a rating, but you've also provided a review. Right? Okay. So if you're looking at beers, right, you might find the beer to be nutty or hoppy. Okay. So we'll also predict sort of the main key phrases, right, from a large list of key phrases that we think describe the item in a personalized way for you, right? These come from the latent embedding of the user and the item, so it is personalized. Okay. So that's the explanation part, just another head for the neural network. Now let's add the critiquing feedback loop. So now you say, you know what, I don't want a nutty beer, I don't want a hobby beer, right? Give me something new. So I'm going to feed back, right, from the explicit critiques back into the latent embedding. Okay? This is interesting, right? We did this paper, we came to think of critiquing as the inverse of explanation. Explanation is going from the latent embedding of the user item, right, to the explicit key phrases or attributes, and the critiquing is going from the explicit attributes back to the latent embedding, right? And they really are sort of inverses. If you look at the paper, that's how we train them. Now you have to combine the critiquing feedback with the latent space, right? And I mean, I will say, you know, we did, you know, take a limited approach with one step critiquing this paper, but getting everything to train well was a bit of an art. You can read the paper for more details. Okay. We did have variational and probabilistic and deterministic versions, and I'll show you the advantages of the variational method in a second. Okay. And the key thing was, I mean, if I took out the critiquing feedback loop, it would not be hard to train this thing. It's more or less a standard explainable recommender, right? But getting the critiquing feedback loop to train well, to align with the explanations, that was where the contribution of the paper came. I will say, if you read the training of the paper, it is quite complex. I'm not necessarily happy with it, but I'm happy if others can build on this work and do better. Okay, so we want to evaluate, right? We need reviews with generic descriptions. So maybe you went to a restaurant and the waiter spilled water on you, but I can't use that description for someone else. So we chose beer and Amazon, CD and vinyl. These are data sets posted by Joe McCauley. These tend to have generic descriptive reviews, like the beer's hoppy, the beer's nutty, etc. We sort of need these generic descriptions. Now, what are things you want to have to hold for deep critiquing, right? Well, when I predict personalized explanations, they should be personalized. They should be just sort of top item key phrases and top user key phrases. Okay. You can take my word for it, that does hold, right? It's in the paper. Obviously, the recommendation quality of system without critiquing should be very good, right? You see that in the paper. Key thing is, we want the items, for critiquing to work, we want to make sure the things that were critiqued actually fall in rank. Now, if it was explicit attributes, that'd be trivial, but these are latent, right? So we had to think of ways to evaluate this. And I'll show you how we do that in a second. Okay, and finally, you will see a failure now. You will see some failures here in the examples, and we're going to do an analysis of what happened in those cases. Okay, now all of our code is online. If you have a good memory, remember this. Otherwise, just same link to the paper. Okay, so we defined this this metric called falling map. You may not like it, but it's the best that we could do for trying to capture that critiqued items would lower in rank. So let's say that in my initial recommendation list, I give items and I critique a key phrase and I draw a check if the item is predicted to have the predicted key phrase, right? So this is before critiquing, right? After critiquing, obviously, I want those items with those key phrases to drop in the rank. So if I look at the average position before and after, right, of items with the key phrases, I would expect that that metric to fall, right? So we call this average position or falling map. Okay. Now this doesn't capture everything you want to happen for the reading system, but it's certainly something that should hold, right? Things that I critique that are highly likely to be descriptive of the item should drop in ranking. Okay. So let's see how things work. We're going to compare collaborative, explainable, variational NCF with the deterministic version without the variational part. Okay? And basically, we did have personalized key phrases, we did have state-of-the-art recommendation, the critiques did align with the explanation fairly well in those cases. We get reasonably high falling maps. If you go to the other case of Amazon seeking vinyl, right, you can find here actually the deterministic case didn't work at all, right? And let me explain that here. Okay, and so this is a well-known problem. When you're training these latent embeddings, you can often get to the problem of mode collapse. So on the left here you have the variational training with the KL divergence term. On the right you have the deterministic training, which does not have the KL divergence term. And you're finding here that when you look at here were the original embeddings for items, here were the critiques and how they were sort of co-embedded back into the latent space. You see, in many cases, the deterministic setting happened to just have a mode collapse, right? It didn't distribute the critiques throughout the explanation space, whereas in the variational case, we rarely ever saw this mode collapse. So this is one advantage to the variational training in this case. It prevents this problem of mode collapse. And that explains in the previous slide why variational tended to do better on average. Okay. So I'm running out of time, so let me just say, we are looking at multi-step sequential critiquing. We only did one critique steps here. We have many ideas. Review our future papers and you'll see them. We obviously want to go to sequential critiquing evaluation. But I mean, this is obviously either a user study, which is time consuming. We're going to figure out how to simulate your users. And that requires a lot of assumptions. We're struggling with that now. Come on my poster if you have ideas. Right? And finally, we did use keyphrase attributes, and that's not where we started, right? We really wanted to start with, general RNNs feeding in sequential language. That never worked for us, right? We're still trying to make that work, but that is our goal eventually. Okay, so you say, great, this is great research, how is it involved? Well, if you're a PhD student, please come postdoc for me. Now you say, I'm for industry salaries, fine, I get it. But if you're interested in this work, I still say, please note we have a workshop on interactive conversational recommendation. We have AAAI 20. Submission deadline is in November, and the conference is in February. So if you're interested in this work, please join this workshop. Like that. Thank you, and I'll take questions.
Time for questions.
Thank you for the talk. I haven't read your paper, but I'm still a little bit confused about the application of what you just presented. Can you give us a real-life example where this in the news or on the web that could be used and how exactly?
Give an example of we didn't do news, right? So the system in the beer case will say, here, we've seen your history of beer ratings. Here's a beer we think you would like, right? And you say, and we say, okay, here's a nutty hoppy beer and some other descriptions. You say, actually, I don't like nutty and hoppy, right? So you critique these things, and then I recommend for a second time, right? After critiquing. And obviously, those critiques should take into account, the second round of recommendations should take into account the fact that I critique some things. And what's interesting about this paper is that the attributes were not explicit of the items, right? They were all learned through personalized explanation. Right? Okay, please.
So if this continues, like this learning continues with the user, and you continue to personalize for the user, how do you avoid what the previous presentation showed, the filter bubble? Basically, some user can give you some feedback, but then you take the path of not showing them specific things because you learn that this person doesn't like this kind of beer, but then maybe in the future they would like that kind of beer. Or learn more about what Trump is doing in Greenland. But you never give them that piece of news again because you've learned that through the critique that they don't like this piece of information. So how do you make sure you avoid that happening?
Well, I don't know how to avoid the problem. It is a problem, right? When should the critiques override the preferences? What role should they play? Let me argue away your question by saying, hey, that's future work, right? We are looking at sequential case. It is hard, and these issues could come up, and I don't think we have a solution yet. But by the deadline, we should have a solution.
Sorry. Thanks for the talk. Just a real quick question. here you've kind of focused on critiquing, but underlying this, you're trying to kind of imbue that latent space with some sort of semantics that represents a user's preference.
Right.
Any thoughts as to how you might use this for other modes of interaction, like actually explicit preference presentation? Thanks along those lines.
Thanks, Greg. I mean, we're thinking about explicit purpose elicitation. I wish I could give you an answer. I mean, certainly I mean, Craig, you've done the purpose elicitation POMDP. This is, I think, a beautiful way to frame purpose elicitation as a sequential framework. And obviously, you have this very short latent embedding. It gives you a probabilistic distribution over the latent space. We are thinking about how to, how to use that purposely belief updating with the purpose elicitation scenario. But I do encourage you in 2019 to find any PhD student who knows what POMDP is.
So we can go to the last presentation. Let's try to go with people.